If you've been watching Mastertech, you're probably well aware of the important work the Automotive Youth Educational System, or AS, and the Chrysler Dealer Apprenticeship Program, or CAP, have been doing to attract young people to the automotive service industry. As you probably know, the purpose of AS is to encourage younger students to look into automotive service as a career and to provide training opportunities to junior and senior high school students. This training can lead to participation in the college-level CAP program and a career at a Chrysler dealership, allowing dealers to grow their own. Recently, 130 instructors from AS, CAP, and AASCP, the GM counterpart to CAP, attended a conference in Detroit to discuss issues related to the programs and to learn about changes in automotive service. During the week of July 13th, conference participants were able to sit down and talk about these topics with Chrysler and General Motors personnel, including Bill Boyd, who is Chrysler's National Technical Training Manager and Vice President and Treasurer of AS. In some of the discussions, participants concentrated on ways of increasing participation in AS and increasing the program's effectiveness. There are now 78 AS schools in 16 states, but the goal is to have 100 by year's end and 700 by the year 2003. Attracting high-quality students, getting greater dealership involvement, and rewarding dealership personnel for participation all came up for discussion. So did establishing closer links and better continuity between the AS program and CAP and AASCP programs. Some of the activities were aimed at bringing instructors up to speed on technical developments at Chrysler and GM. By the time the conference ended on July 17th, participants had discussed solutions to the most pressing issues facing AS, CAP, and AASCP, and they were better informed about changes in automotive service. While we're in the area of training and certification, let's take a quick look at a few automotive service excellence developments. The fall ASC test dates are November 5th, 10th, and 12th. Keep in mind that the deadline for registration is October 2nd. In a related development, a Spanish glossary will soon be available for ASC test takers who are not native speakers. This glossary can also be used by reader translators when they assist those being tested. Another development on the ASC front is consumer research to find out just how the public views ASC certification and how to improve the image the public has of technicians and their work. Speaking of work, let's move on to the main subject of this Mastertech release, the 4.7-liter engine.
With the introduction of the 1999 Jeep Grand Cherokee comes an all-new engine, the 4.7-liter single overhead cam V8. The new engine represents a radical departure from previous Chrysler V8 engines in a number of areas. These features allow the 4.7-liter engine to be smaller and lighter than its predecessor, yet produce more horsepower and equivalent torque. The new engine also allows the Grand Cherokee to achieve better fuel economy with lower emissions. Welcome to this month's Mastertech. The purpose of this program is to acquaint you with technical features of the 4.7-liter engine and related engine systems with an emphasis on critical service features. At the beginning of each main segment, we'll state the training objectives so you know what we're trying to achieve. Let's get started with an overview of the 4.7-liter engine. In this segment, we're going to take a look at the engine's general features, and after watching it, you should be able to describe the general characteristics of the 4.7-liter engine. As mentioned at the beginning of the program, the 4.7 is a single overhead cam engine. That is, one cam on each cylinder head operates the intake and exhaust valves. The crankshaft drives a primary chain which turns the idler sprocket assembly. The idler sprocket assembly, in turn, drives two secondary chains which turn the camshafts. The 4.7-liter uses two valves per cylinder, and it's important to keep in mind that the intake valves can contact the pistons if the engine is timed incorrectly. It is not a freewheeling engine. The cylinder heads themselves are aluminum, and we'll discuss some precautions later on that you'll need to take to ensure good sealing. The cylinder block is cast iron with a separate component known as a bed plate making up the bottom of the block. The bed plate contains the caps for the main bearings, which are select fit. That is, the bearings are individually matched to the crank journal, with the size indicated on the crankshaft zone wheel. The components which make up the 4.7-liter engine were designed to seal without the use of sealing compounds. In fact, the area where the bed plate and the block meet is the only mating surface where sealer is needed. At the top of the 4.7-liter engine, you'll notice a composite intake manifold, and if you could see inside of it, you would see a central tube from which air travels through long runners to the individual cylinders. The 4.7's fuel, ignition, and cooling systems also have some features that make this engine different from its predecessors. For one thing, the systems use a new engine controller, the J-Tech Plus. In addition to the sequential multi-port fuel injection, the J-Tech Plus controls an ignition system that is new to Chrysler V8 engines, coil on plug. Also new is the hybrid cooling fan system, which consists of a mechanical and an electric fan. The electric fan is pulse width modulated and is also controlled by the new PCM. As you might expect, there are some new special tools which you'll need to use when working on the 4.7-liter engine. In fact, there are 14 new special tools, many of which you'll see in use during the rest of this program. Now, since we already have an engine on a stand, one of the tools we won't be seeing in action is the engine lift fixture. But it can help you avoid a lot of grief when taking an engine out of a Grand Cherokee. You should always use the lift fixture special tool 8347 to remove the 4.7-liter engine from the Grand Cherokee. Never use the two studs on top of the engine to lift it. Doing so can create a safety hazard. Now that we've covered some of the general features of the 4.7-liter engine, let's try a review question to check what you've learned. It's a good idea to stop the tape to discuss the question before answering it, as well as to review the information in this segment. Which of the following is a general feature of the 4.7-liter engine? A. 4 valves per cylinder. B. Single overhead cam design. C. Aluminum intake manifold. Or D. Freewheeling engine. The answer is B. Single overhead cam design. The 4.7-liter uses 2 valves per cylinder and a composite intake manifold. It is not freewheeling. In this segment, we're going to cover front-end features of the 4.7-liter engine, including some procedures related to timing. After watching this segment, you should be able to describe front-end component features and the use of special tools during service, explain timing verification and correcting timing of a single camshaft, and explain how to check secondary timing chains for stretch. In our look at the front end, let's begin with the accessory drive features. The accessory drive components use a serpentine belt. As in the past, when installing a belt, you should use the routing label under hood or the service manual to make sure the belt is routed correctly. Note that on the 4.7-liter engine, the generator and compressor mount directly on the timing cover, not on brackets, and that the power steering pump mounts directly on the cylinder head. Eliminating brackets helps reduce noise, vibration, and harshness. The water pump also mounts on the timing cover, and you'll need to use a spanner wrench, special tool 6958, along with adapter pins 8346 to remove the viscous fan drive. Note that these are not new special tools, but ones that should have already been used for another application in your dealership. On the other hand, some of the tools used to remove and install the crankshaft damper are new. These include the insert special tool 8513, which is used with puller 1026 to remove the damper, and special tool 8512, which is used to install the damper. Because the 4.7-liter engine is non-freewheeling, it's important to know how to verify whether the engine is in time and what to do if it isn't. To verify engine timing, you'll first need to remove the cylinder head covers. Then set the engine to top dead center by aligning the TDC on the timing cover with the notch on the crankshaft damper. At this point, if the engine is in time, both of the V8 marks on the camshaft sprockets will be at either 12 o'clock or 6 o'clock, depending on whether the number 1 cylinder is at TDC on the exhaust or the compression stroke. If neither of the V8 marks line up, the timing is off between the primary and secondary chains, and you'll need to follow the timing drive removal and installation procedures detailed later in this program. If only one of the marks is off, one of the camshafts is out of time, and you'll need to perform a single camshaft timing procedure. To do this, you must first prevent the tensioner piston and ratcheting device from moving outward by installing special tool 8350 chain tensioner wedge. After removing the sprocket bolt, you can then remove the camshaft sprocket and reposition it on the chain so that the V8 is in the same position as the V8 on the side that is in time. At this point, you need to rotate the camshaft to bring it into alignment with the sprocket. When the dowel on the camshaft aligns with the slot on the sprocket, you can install the sprocket on the camshaft. Use special tools 6958 spanner wrench and 8346 adapter pins along with a torque wrench to tighten the cam sprocket retaining bolt. And don't forget to remove the chain tensioner wedge when you're done. Front and rear oil seal installation is another procedure that requires the use of some new special tools. Be sure to use the special tools listed in the service manual or on the MDS2 to remove and install these seals, or you may damage the crankshaft. The 4.7-liter engine's timing chain cover is bolted to the front of the block. In addition to accessory drive components, several of the engine's cooling system components are installed on the cover. Some 4.7-liter water pump features were covered in July's Mastertech. You may remember that the pump uses a chamber to allow the fluid that normally escapes past seals to vaporize. Another new feature of the water pump is that the water pump and pulley are one assembly and are not serviced separately. The thermostat housing is also located on the timing cover. Notice that the thermostat is located at the water pump inlet instead of at the outlet, as on previous engines. Also note that the back of the thermostat partially restricts the bypass passage as the thermostat opens. By the way, the cooling system for the 4.7-liter engine uses conventional ethylene glycol coolant. However, keep in mind that you will need to use the bleed plug during refilling to make sure there's no air pockets in the cooling system. We'll cover the use of the bleed plug later on in the program. The water pump and thermostat housing can remain on the timing cover during removal. The timing cover uses a silicone-type gasket with a steel backbone. Take care not to nick or scratch the area where the timing cover meets the block, since a smooth surface is critical to good sealing. Earlier in the program, when we discussed the general features of the 4.7-liter engine, we took a brief look at the timing drive system. At this point, let's take a closer look at how the 4.7 times valve operation to piston movement. The primary chain runs from the crankshaft sprocket to a sprocket on the idler assembly. There are marks on the crankshaft and idler sprockets and plated links on the chain for initial timing. A one-piece mechanical tensioner and fixed chain guide keeps the primary chain in place. The primary chain and tensioner are lubricated by leakage from the front of the pump. The secondary chains run from the idler assembly sprockets to the camshaft sprockets. For timing, plated links on the chain must align with slots in the primary chain sprocket. As we saw earlier, V8 markings on the camshaft sprockets are used to indicate that the cams are in the correct position. There's also a plated link on each secondary chain which must be aligned with the L or R dot when positioning the chain on the sprocket. The secondary chain tensioners use engine oil pressure and a ratcheting mechanism to maintain pressure against the secondary chain tensioner arms. The tensioner arms maintain minimum tension in the secondary chains. The fixed chain guides keep the tight side of the chain in position. An orifice in each of the secondary tensioners sprays engine oil on the secondary part of the timing drive system. Slots in the cam sprockets fit over dowels on the cam shafts. Note that the tone wheel for the camshaft position sensor is riveted to the right camshaft sprocket. The tone wheel and sprocket are replaced as one piece. The tone wheel is very sensitive to damage, so you'll need to be careful not to damage it when working on the engine. You can check the secondary chains for stretch by measuring how far out the piston has extended from the secondary tensioner. To do this, first rotate the engine so that the chain tensioner piston extends fully. Then measure the distance from the tensioner housing to the step ledge on the piston. The distance must be less than 15 millimeters. If it exceeds this, you'll need to replace the secondary chain and inspect the other timing chain components for wear. Now that we've discussed features on the front end of the 4.7-liter engine, try this review question to test your knowledge. You may want to stop the tape to discuss the question before answering it. It's also a good time to review the material in this section. While verifying engine timing, you discover that both V8 marks on the cam sprockets are off when the crankshaft is at TDC. This indicates A, the engine is in time, B, one camshaft is out of time, C, timing is off between the primary and secondary chains, D, none of the above. The correct answer is C. If both marks are off during the timing verification, it indicates that there's a problem between the primary and secondary chains, and you'll need to disassemble the timing drive system to re-establish the correct timing. In this segment, we're going to cover servicing the timing drive system. After watching this segment, you should be able to explain, in general terms, how to disassemble, inspect, and reassemble the timing drive system. To access the timing drive system components, you'll need to remove a number of components from the front of the engine as detailed in the service manual or on the MDS-2. Before removing the timing cover, you'll also need to make sure that the crankshaft timing marks are set to TDC, and the V8 marks on the camshaft sprockets are in the 12 o'clock position. Once you gain access to the timing drive components, the first step in their removal is to collapse and pin the primary chain tensioner using special tool 8514. Remove the secondary chain tensioners next. When removing the left tensioner, take care not to let the plate behind the tensioner fall into the oil pan opening. Remove the camshaft position sensor from the right cylinder head and then remove the camshaft sprocket bolts. To remove the sprockets, hold the camshafts on the tube part between the lobes. Take care not to contact the lobes and never hold the right camshaft with the tone wheel. After removing the sprockets, rotate the left camshaft 15 degrees clockwise to a neutral position, and rotate the right camshaft about 45 degrees counterclockwise to a neutral position. At this point, you can remove the idler assembly bolt and then slide the idler assembly, chains, and crankshaft sprocket from the front of the engine. To complete the disassembly, remove the pivoting tensioner arms and chain guides. When inspecting the timing drive system components, Keep in mind that some tooth wear is normal on the sprockets. When inspecting the idler assembly, turn the primary and secondary sprockets in opposite directions to check for wear. Also, check the idler assembly shaft and bushing for wear. Inspect the faces of tensioner arms and chain guides and replace any that have scoring deeper than 1 millimeter. Deeper scoring may be evidence of lack of lubrication. If that's the case, you'll need to replace the chain tensioners as well, since they may have failed to provide the necessary lubrication. Once you've inspected the components and replaced any that are worn or damaged, you can begin putting the timing drive system back together. Begin by installing the chain guides and the chain tensioner arms. When bolting on the chain guides, be sure to use the shorter bolts in the block and the longer bolts in the cylinder heads. When installing the tensioner arms, be sure to use Mopar lock and seal on the bolt threads. The next step in the installation procedure involves assembling the chains on the idler and crankshaft sprockets and installing the assembly on the engine. To prepare the parts for assembly, first lubricate the bushings inside the idler assembly, as well as the idler shaft on the engine. Then place the secondary chains on the idler sprocket so that the two plated links on each chain are visible through the lower slots in the primary idler sprocket. Install special tool 8515 on the idler assembly to hold the secondary chains in place. Next, install the primary chain on the idler sprocket so that the two plated links on the chain align with the mark at the 12 o'clock position on the sprocket. Position the primary chain on the crankshaft sprocket so that the single-plated link on the chain aligns with the mark at 6 o'clock on the sprocket. At this point, you can install the secondary chains, idler assembly, primary chain, and crankshaft sprocket on the front of the engine. Next, install the left cam sprocket on the chain so that the L dot on the sprocket aligns with the plated link on the chain. Install the right cam sprocket so that the R dot aligns with the plated link on the chain. With the cam sprockets in place, you can remove special tool 8515 from the idler assembly. To install the camshaft sprocket bolts, you'll need to rotate the camshaft slightly. Install the bolts finger tight so that the sprockets are secured to the camshaft. The secondary chain tensioners need to be reset and pinned before you can reinstall them. To do this, place the tensioner in a vise and compress it until the piston step is flush with the tensioner body. Next, insert a thin tool in the access hole on the side of the tensioner, and while holding the ratchet pawl back, push the ratchet inward until it is about 2 millimeters from the tensioner body. Then insert the lock pin, special tool 8514, into the hole on the front of the tensioner. Release the vise to allow the piston to expand against the locking pin. With the secondary chain tensioners reset and pinned, you can install them on the engine. If you've installed the components correctly, the V8 marks on the camshaft sprockets should be at the 12 o'clock position and all the other timing marks should still be aligned. If the marks are aligned, you can lubricate the idler assembly bolt threads and washer with oil and install the bolt on the engine. At this point, you can pull the locking pins from the primary and secondary tensioners. Take care not to manually extend the tensioner ratchets, since this will result in excess tension on the chains. To tighten the cam sprockets, use the spanner special tool 6958 with adapter pins 8346. Once the cam sprockets are tightened to specification, it's time for a final verification of the timing marks. To do this, rotate the engine 2 full revolutions and check the timing marks. The primary chain crankshaft mark should be at 6 o'clock, while the primary chain idler sprocket mark should be at 12 o'clock. Both of the camshaft sprocket V8 marks should be at the 12 o'clock position. The plated links will not line up at this point. If the timing marks are in the correct position, you can lubricate the chains with oil prior to reassembling the front of the engine. Also, the service procedure recommends checking the idler gear end play. Now that we've covered timing chain removal and installation, see if you can answer this review question. You may want to stop the tape to discuss the question before answering it, as well as to review the material in this segment. How do you ensure that the secondary timing chains are located properly on the idler sprockets during timing chain installation? A. The dots align with plated links. B. The V8 marks are at the 6 o'clock position. C. The plated links are visible through slots. Or D. The crankshaft slot aligns with the TDC on the cover. The correct answer is C. When the secondary chains are positioned correctly on the idler sprockets, the plated links are visible through the slots. In this segment, we're going to look at components on the upper end of the 4.7-liter engine. After watching this segment, you should be able to describe features of the 4.7-liter engine upper end, including the intake manifold, cylinder head covers, camshafts, rocker arms, lash adjusters, and cylinder heads. One feature of the 4.7-liter engine upper end that's sure to catch your attention is the intake manifold. Instead of aluminum, the one-piece intake manifold is made of a composite material. Inside the manifold, a central tube from the throttle body connects to 8 20-inch runners, which deliver air to the individual intake ports on the cylinder heads. The manifold uses individual rubber gaskets for each port. When servicing the intake manifold, keep in mind that you'll need to loosen and tighten the fasteners in sequence. When you look at the removal and installation procedure in the service manual or on your MDS-2, you'll also notice that it's a good idea to remove the cowl to hood seal, since it helps the intake to clear the cowl. The cylinder head covers on the 4.7-liter engine may also be different from what you're used to seeing. The covers are made of magnesium for weight savings and are isolated from the heads to reduce noise, vibration, and harshness. It's crucial to route components in the engine compartment so that they do not rub against these covers, since the magnesium could be worn through. The 4.7 liters camshafts are a new design. The camshafts use a steel tube which the lobes are bonded to. A nose piece is friction welded to the tubes. A thrust wall at the front of the camshaft controls end play. The camshafts each have 5 bearing journals. However, the left and right camshafts are not interchangeable. The camshaft bearing caps are marked to show their orientation and position on the cylinder head. You should never stamp the bearing caps to identify them. If you do need to remove the camshafts from the engine, be sure to refer to the procedure in the service manual or on your MDS-2 to prevent problems. The procedure contains such information as the correct sequence for removing and installing the bearing caps, and the use of special tool 8350 to prevent the secondary tensioner piston and ratchet from extending. Rocker arms on the 4.7-liter engine use a roller to transfer motion from the cam lobe to the valve spring. Stationary lash adjusters are mounted in the cylinder head. You can remove the rocker arms and lash adjusters with a camshaft installed if you use special tool 8516. Take care to install the lash adjusters and rocker arms in their original positions. It is possible to install the rocker arms backwards. The way the camshafts, rocker arms, and lash adjusters receive lubrication may be different from what you're used to and deserves a closer look. The main oil gallery in the cylinder head feeds the camshaft and lash adjuster towers. The camshaft towers feed the cam bearings. In addition, the number 3 camshaft bearing journal feeds the camshaft tube. The camshaft tube feeds the cam lobes and rocker arms for the intake valves. The lash adjuster towers feed the lash adjusters, rocker arms, and cam lobes for the exhaust valves. Speaking of valves, the valve springs and stem seals are the same for intake and exhaust. You'll need to remove the cylinder heads to service them. The 4.7-liter engine's cylinder heads are made of aluminum with pressed-in valve guides. The guides are not serviceable. There are a few items you need to keep in mind during cylinder head service, such as setting the engine to top dead center and marking the cam sprockets in relation to the chains prior to unbolting them. When unbolting the cylinder heads, don't overlook the 4 smaller bolts at the front of each one. The cylinder heads use multi-layer steel gaskets, and the head and block surfaces must be smooth if it is to seal properly. For that reason, do not allow the cylinder head sealing surface to contact anything which could scratch it. And use only a plastic or wooden scraper, and if necessary, brake cleaner to clean the head. The same precautions apply to the block sealing surface. The cylinder head bolts are reusable, but you'll need to check them for stretch. And you'll need to apply Mopar lock and seal to the threads of the 4 smaller bolts. The cylinder head bolts are tightened using a torque plus angle method. As always, be sure to refer to the information in your service manual or on the MDS2 for the exact removal and installation procedures. Next, we're going to look at the engine lower end. Before we do, try this review question. Once again, it may be helpful to stop the tape and review the material in this segment before proceeding. What is an appropriate method of cleaning the cylinder head sealing surface? A. Wire brush. B. Plastic scraper. C. Fine grit sandpaper. Or D. Razor blade. The correct answer is B. It's essential to use only cleaning implements or solutions which will not mar the cylinder head sealing surface. At this point, let's take a look at the components and features at the lower end of the engine. After viewing this segment, you should be able to describe features of the 4.7-liter engine lower end components, including the structural cover, oil pan, pan gasket windage tray, oil pump, bed plate, main bearings, and pistons. The structural cover makes the engine to transmission connection more rigid and thus helps reduce noise, vibration, and harshness. It's important to use the tightening procedure in the service manual or on the MDS2. If you don't, you can easily damage the structural cover. The oil pan on the 4.7-liter engine features a laminated metal-plastic-metal construction, which helps to reduce noise, vibration, and harshness. The pan gasket and windage tray are combined into one component, which is fastened to the bed plate independently of the oil pan. As a result, the gasket will not drop down when the pan bolts are removed. You'll need to remove the gasket windage tray fasteners separately. When installing the pan gasket windage tray, be sure to start 4 bolts at the corners before tightening the oil pickup tube bolts. Doing so helps to maintain the gasket alignment. The 4.7-liter engine uses a gerotor-type oil pump, which is driven by the crankshaft nose. You'll need to remove the timing drive system components as described earlier to access the pump. Keep in mind that if the relief valve or any other oil pump component is not working properly, you'll need to replace the pump since it is serviced as an assembly. The bed plate used on the lower end of the 4.7-liter engine makes the engine more rigid, another measure aimed at reducing noise, vibration, and harshness. The bed plate also serves as the cap for the engine's main bearings. To ensure a good sealing between the bed plate and block and correct clearance in the main bearings, it is critical to follow the installation procedure in the service manual or on the MDS2, especially in regards to sealant application. For one thing, it's important to apply the correct amount of sealer in the right pattern to ensure a good seal. Also keep in mind that the sealer used is RTV, not the anaerobic sealer you may be used to. So you must install the bed plate before the sealer begins to harden. To obtain a good seal, you'll also need to use the tightening sequence, which is detailed in the service manual and on your MDS2. The main bearings on the 4.7-liter engine are select fit. That is, individual bearings vary depending on the diameter of the crankshaft journal, and may be one of 3 sizes referred to as grades. You can determine what grade a main bearing is by looking at the letters on the crankshaft position tone wheel and referring to the chart in the service manual or on the MDS2. For example, suppose that the first letter on a tone wheel is C. That means the number 1 main bearing is 4/10,000ths of an inch thinner to compensate for a crank journal that is slightly larger in diameter than the standard size. The crankshaft thrust washers consist of 2 separate pieces that can only be installed one way. They are located on the block side of the number 3 main bearing. The 4.7-liter engine uses aluminum pistons with powdered metal connecting rods. The piston has an anti-friction coating on the skirt, and the connecting rod uses a cracked cap design. That is, during manufacturing, the rod end is fractured to form the bearing cap. Be sure to mark the bearing caps and connecting rods with an indelible marker prior to disassembly, so they can be reinstalled in the same location and orientation. Do not stamp the caps to identify them. Before removing or installing the pistons, install special tool 8507 on the connecting rods to protect engine components. The 4.7 liters piston and connecting rod are serviced as an assembly, and there is only one size and weight available. You can ensure proper connecting rod and piston orientation by looking for the oil slinger slot on the connecting rod, which must face forward. The F on the piston pin boss also indicates forward. Next, we're going to move on to the features of the engine-related systems. But first, let's try this review question to check your knowledge. On which of the following 4.7-liter engine components must you tighten the fasteners in a particular order? A. Structural cover. B. Pan gasket windage tray. C. Bed plate. Or D. All of the above. The correct answer is D. With all of these components, you must tighten the fasteners in a certain order. In this segment, we're going to cover features of engine-related systems. More specifically, after watching this segment, you should be able to describe new features of the PCM and its inputs and outputs, explain the operation of the coil-on plug ignition system, describe new features of the evaporative emissions and fuel injection systems, and explain how the PCM controls the electric fan. Accompanying the new 4.7-liter engine is a new powertrain control module, the JTEC Plus. Compared to its predecessor, the JTEC Plus operates at a higher speed and offers more features such as full-range misfire detection. In addition to the PCM itself, some PCM inputs and outputs have changed. For one thing, the PCM now receives the vehicle speed signal from the anti-lock brake controller, which derives its data from an average of the 2 rear wheel speed sensors. Speed control switches have different resistors, and as a result, their input voltages are different than in the past. On the output side, a change in the power supply from the PCM to the fuel level sensor results in a higher voltage level for the same amount of fuel. On California emissions packages, the PCM controls 2 O2 heater relays which power 4 O2 heaters, 2 upstream and 2 downstream. The PCM can avoid a sudden change in electrical load by delaying turning on the downstream heaters. It can also turn off the heaters under certain conditions to prolong heater life. Our next PCM output represents a quick way to read diagnostic trouble codes even before you hook the DRV3 up to the Grand Cherokee. Cycling the ignition key from off to on 3 times causes the PCM to display diagnostic trouble codes in the odometer. Notice that these are P codes, not the more general 2-digit codes. Earlier, we mentioned that the coil-on plug ignition system was one of the main features of the 4.7-liter engine. With coil-on plug, each cylinder has its own coil assembly connected directly to a spark plug. The system eliminates the need for both the distributor and secondary ignition wires. The coils receive power from the ASD relay. The PCM controls the ground side to turn the coils on and off. The PCM can vary the saturation time of the coils based on engine RPM and battery voltage. Normally, coil saturation time ranges from about 3.7 milliseconds at lower RPM to about 2.4 milliseconds at higher engine speeds. If you are used to passenger car coil-on plug systems, keep in mind that the system on Grand Cherokee operates at a higher amperage. In addition to the crankshaft position sensor signal, the PCM now depends on the cam sensor position signal for ignition timing. The engine will continue to run if the PCM loses one of the sensor signals. However, it will not start without the cam sensor signal. If a sensor signal is missing, it may affect engine performance. For example, without a crank sensor signal, among other things, the engine will be limited to a maximum RPM of about 2,800. At the end of the coil-on plug system is a copper core ground electrode spark plug that has a service interval of 30,000 miles. As mentioned in the 1999 Grand Cherokee Highlights program, all Grand Cherokees with a 4.7-liter are equipped with a leak detection pump and a secondary seal in the fuel filler neck. When servicing the evap system, keep in mind that the 4.7's purge duty cycle at idle may be lower than other applications you're used to working on. The 4.7 liters fuel injection system has some sophisticated features which are aimed at conserving fuel, improving drivability, and extending component life. For one thing, under certain conditions, the PCM can reduce the idle speed to 500 RPM to reduce fuel consumption. Under most other conditions, engine idle speed is 600 RPM. On the other hand, the PCM can increase fuel at wide open throttle based on what it sees in adaptive memory. For smooth shifts and to extend component life, the PCM uses something called shift torque management. During upshifts near wide open throttle, the PCM retards the spark and shuts off fuel to every other cylinder. To protect components, the PCM also practices engine RPM management in relation to transmission stall speed. This helps protect components if an operator rocks the vehicle or if the transmission is shifted into drive from neutral at higher RPM. The final PCM controlled system we need to look at is the hybrid cooling fan system. As you saw during the Grand Cherokee Highlights program, the Grand Cherokee uses an electric and a mechanical fan. The mechanical fan is used for highway driving and trailer towing. When not coupled through the viscous drive, it rotates at about 300 RPM. The PCM operates the electric fan at idle and low speeds using pulse width modulation. There are 2 duty cycles. Keep in mind that the electric fan does not necessarily come on with the AC as it does on some other vehicles. Now that we've taken a brief look at some of the 4.7-liter engine systems, let's check your knowledge with a review question. It's a good idea to pause the tape and review material in this segment before answering the question or proceeding to the next segment. Which of the following is not a feature of the 4.7-liter engine coil-on plug system? A. Secondary ignition wires. B. A coil for each cylinder. C. Power for coils from the ASD relay. Or D, coil grounds from the PCM? The correct answer is A, secondary ignition wires. Because each coil assembly connects directly to a spark plug, there are no secondary ignition wires. In our final segment on the 4.7-liter engine, we're going to look at the coolant refill procedure. After watching this part of the program, you should be able to explain how to correctly refill the cooling system to avoid an air pocket. As on other cooling systems, before refilling, first make sure that the radiator drain cock is closed. Then remove the coolant bleed plug from the top of the timing cover. Next, fill the radiator with a 50-50 mixture of antifreeze and water. When the coolant reaches the top of the bleed hole, you'll need to apply thread sealant to the plug threads and install the plug. Next, fill the coolant reservoir to the full mark. After installing the radiator and reservoir caps, start the engine and run it at 3,000 RPM for 10 seconds. Then shut the engine off, remove the radiator cap, and once again fill the radiator and install the radiator cap. It's important to perform this procedure every time you refill the cooling system for the 4.7-liter engine. Simply filling the radiator will most likely result in an air pocket and resulting engine overheating. That about does it for this look at the 4.7-liter engine and its related systems. Be sure to refer to the Grand Cherokee Service and Diagnostic Manuals and your MDFs-2 for detailed information about the procedures we've looked at in this program. And be sure to join us next month for a look at the highlights of other 1999 models.